understanding.
You were given enough to grade all the presentations. You were supposed to keep them. Right here. Is it hooked up? Sorry,
It's coming.
Okay. Okay. Hello, everyone. Good afternoon, investors. We are Advanced Idea Mechanics. And just to kick things off, I'm going to introduce myself. I'm Casey Lanier, and this is my brilliant, innovative team at AIM.
I'm the chief engineer behind this whole operation, Val.
I'm the marketing director of Vismet.
I'm one of the scientific research team.
I'm one of the researcher, Valerie.
I'm the funding manager, Jonathan.
Marketing manager, Lynn Family.
Research development, Carl.
As I said, we're Advanced Idea Mechanics, and we aim
To
give
give
you
you
the
the
power. The mission of our company is to create effective, economical biotechnology using regenerative cells as alternate energy sources. Our product that we've designed is called the Force. I'm going to hand it over to our Force designer to explain a little more.
So how is everyone doing today? This is the Force. Using GMSC, genetically modified self-replicating cells, we use that particular cell to infuse it into a highly electrically conductive gel, which amplifies electricity output. And as a result, we have a portable power cell battery that's low maintenance and self-sustaining. I'm going to pass it over to our marketing director.
All right. Now you may be asking yourself, why would I want that? Now, yes, you have a laptop charger. Yes, you have an iPhone charger. Yes, you have a car charger. But do you see what the problem with these devices are? They all require an outlet. Now, you know what? With our product, forget that the outlet even exists, because this amazing device here charges all of those with just a simple USB port. So the Force has an impressive voltage output. It dishes out over 100 volts for over 150 hours. And that's enough to power your laptop for a couple of days and your cell phone for weeks. It's portable. Now you see it, now you don't. It charges a lot of devices, so it's also versatile. It's regenerative, because with the self-replicating cells, it regenerates its power over time. It's economical. Now I'm sure we all ball on a budget these days. So to help the consumer, we list this device at a mere $29.99. Plus it comes with one accessory, which will be explained later on. And it's environmental. This reduces the millions and millions of pounds of alkaline and lithium battery waste that are accumulated each year and the poisonous effects on our planet Earth. Now, if my words alone are not enough to convince you, I have a short commercial for you to view. Hello, Dr. Xiao. I'm here to introduce to you a product that will change your life forever. This is called the Force. It is a biocell battery that will charge virtually anything with a USB port. It is versatile. It is durable. It is also eco-friendly. This product will not cause any harm to the environment whatsoever.
Hello? Hello? Man, my phone just died again.
Said you want that?
Yeah, it just died on me.
I got the perfect
Oh.
No. What this is called the Force. It's a biocell that powers everyday small devices such as your cell phones, laptops, even a small TV.
Right.
So if you got your charger on you, like I'll show you what I'm talking about.
Alright.
Alright, watch this.
Wow, it's charging.
Yeah, well, that's one of the many things that this thing can do. It can not only charge your phone, but it can also charge many other things, like I said. So, I mean, go ahead and invest in this, because this is probably one of the best things I have bought. He thought it was kind of rocky. Not only does this device charge cell phones, but it can also charge devices as big as a laptop.
This product is amazing. This product has changed my life forever. This is the coolest thing ever. It changed my life forever. You should buy this, the Force. This product is amazing.
If you order within the next 10 minutes, I will go on BioSteel plus a free accessory and free shipping. You know what? Order now.
So I'm going to tell you how this thing works. So what we did is we decided to use the breast cancer gene BRCA1 that had already been isolated by the Institute of Cancer Research in the UK. So we collaborated with the Institute and obtained the gene sequence and replicated it ourselves. And we decided to insert this gene into Agrobacterium tumefacies. Agrobacterium tumefacies is commonly found in soil and is automatically attracted to plant cell. It already swims up through plant roots and inserts the genes or the plasmid DNA into the plant cell. And since plant cells go through photosynthesis regularly in order to survive, they automatically replicate and we get our cancers, our genetically modified self-replicating cells. This is about photosynthesis. Sorry.
Photosynthesis of plant carry out photosynthesis to make energy in the plant. Photosynthesis occurs in the chloroplast of the plant cell. As its name implies, photosynthesis is the process of converting light energy to chemical energy and storing it in the bond of sugar. The photosynthesis have two states. One of the states is the light reaction. The light reaction is having the complex absorbing sunlight in the form of photon. The electron in the photon is very unstable, so they're passing down the complex to stabilize. And as they're passing down, hydrogen from the outside is passing through the photon home to make a photon gradient. As the photon gradient builds up, there's an electric potential that will be put into a conductor and steer the flow of current. Well, our chief of design will walk us through the conductor.
So now that you guys know the scientific reason or the scientific system behind the system, I want to tell you how it works. We're able to use, with this particular system, we're able to control the production of electrons by regulating the amount of water, carbon dioxide, and sunlight needed for the continuation of photosynthesis. Within this particular caps right here, we incorporated tiny solar panels that help us absorb sunlight. The reason why it's flat, it's better to absorb sunlight. So why this works is also incorporated within the gel itself. It is a highly electrically conductive gel. It's made of aniline and phytic acid. Phytic acid is the main storage system within plants. So with that particular, when they work together, they form a biological system that's similar to human tissue, similar to what you'll see in a neuron system. With that, it's able to amplify electricity, also has the ability to hold charge. And not only that, it can be solidified. It can also be used in a gel form that can be taken in any particular shape. What you see here is one of our first model. Be expecting to see more models coming in the near future. Now we'll pass it on to our
Marketing manager.
I apologize for that.
Hello everybody. So now everybody knows our idea and our product. The next step before we put it out in the market is to get a patent so other groups cannot steal our idea. Patent will protect our idea so other competitors won't try to use our ideas to to their advantage. So after we get our patent approved, then our next step is for FDA approval. Why FDA, you think? Because our device uses a cellular component for industrial use. That's why it falls into the jurisdiction of the FDA. And for the FDA, it requires two steps. First step is safety. So we took 100 of our devices, the Force, okay, and we put it through many random tests like drops, spills, to see if we put it through any damage, would it cause any harm to anybody. So we got the green light for safety. So we moved on to our next step, which was efficacy. We had to see if our product was actually effective enough to put out in the market. So through 500 different trials, we took an average of volts that were produced from our product, which was about 100 volts. So that's enough to power, let's say, a laptop for about 150 hours. So we took that, we got the green light for efficacy from FDA. So the next thing, we sent our results to the IRB, the Institutional Review Board, and they would go over all of our testing and all of our paperwork to see if we kind of like mishandled anything or like changed any information to make our product seem a little bit better than it actually is. And then the IRB would actually send it to the FDA. They would say if it's good or not, and after we get the final FDA approval, then we would send it out to the market and get budgeting approved. Our budgeting director, Jennifer, will take over from here.
Hi guys, my name is Gian, and I'll be leading the funding of our company. As you can see here in the bar graph, we are funded by the NSF and the WBT. You might be wondering who they are. The NSF is the National Science Foundation. They're basically a foundation for companies that are in research for biological engineering. And the WBT, they started in 2002 to compile all applications of companies, of new researchers, new innovative ideas for biological reasons. And they actually choose three out of the 603 companies that apply. And what happens to the 3 companies that are chosen, they get granted approximately $77,000 to $78,000. And as you can see here, we were graciously accepted into their program, and we were able to receive sponsorship through the WBT. You can see we received $77,100 through in 2011, and 2012, $78,000. I will tell you a little bit about the breakdown of the 2012 funding that we have. As you can see here, about approximately 65% of our funds go into research. It is still new, so we're trying to make sure we're covering every track. And approximately 15%, approximately 25% goes into the equipments that are needed for our biological cell biobattery, and then the 10% goes into the education. Now you might be wondering, why funding in education? There are approximately so many new research that are developing. There are new scientists, new ideas. So we wanted to make sure that we reached out to all the high schoolers that have all these innovative ideas and use them and educate them in the new possible way of using technology through biology. Therefore, I'm reaching out to you, sponsors and investors, to help us in making this happen. My estimate goal is to educate everybody that's all consumers of the new battery that we are currently developing. And I'm going to actually pass over to Carl, who is our leader development researcher, and he'll tell you about our future goals.
Well, the future goals of AIM, our researchers want to reduce the size of this product. That way, you can fit it in your pocket, you can connect it to keychains, or you can charge up your equipment without people actually knowing. For greater efficiency and greater power, we believe that the Force can power apartments, cars, and even planes. And more importantly, we want our product to be available for people like this, for this person right here, the men and women of our armed forces. This will reduce the load that our soldiers are carrying. This will allow them to decipher intel on the move, even during combat. Eventually, we see our product powering the entire world, available for every country in the world. And these are just a few of our references that we use to research our product.
At this point, we've made our pitch. Now the power of the force is in your hands. It's up to you to make a difference in the world with this charge-it-all device. And as always, may the force be with you.
I do.
Question? We're obviously going to open up to questions.
Okay, so let me try to understand the mechanisms behind it. You're using photosynthesis that plants use for energy to create energy within this tube. And then the current that the electrons are inducing from the chain is being used to charge them?
Yeah, so the current from the plant cells that we gain from photosynthesis, we have a specially made gel that will enhance the electric output from these cells, like enhance the electric potential that was found through photosynthesis.
Where are all like the cofactors that are needed for photosynthesis? And those things are used and need to be replenished. Where are all those coming from?
Like I said, the system itself has ports to regulate oxygen and also has ports to regulate carbon dioxide too. And we also have a solar panel too to reduce.
No, not the actual. I'm talking about the cofactors that are used to actually reduce the protein complexes.
We need a different enzyme. Or
Yeah, like in the mitochondria, NADH would be an example of one
We're
of the
not
cofactors.
using the mitochondria, we are using
Well, I'm saying
plant
it's the
cells
same.
through chloroplasts and baculoles.
I know, but I think you.
I understand what you're saying about like where are the different enzymes that are incorporated into like the plants already and into like the cell. Because you don't really actually lose those enzymes, and like since the plants are like they actually make the proteins themselves because they have their own DNA. So like they're going through the whole like translation transcription thing to like make these growth factors. Yes.
Along that line, so the final product is plant cells in the battery, in your gel matrix.
Yes.
Okay? And to follow up on his question, you have your light and your oxygen. What about things like heavy metals? I believe that's what he's getting at as far as cofactors. So is this a completely sealed system, or do you ever open it up, add fresh media in, something like that, add more cells?
That's why we have the valves so we can add stuff.
So you can add things. So for a consumer, how much maintenance is involved?
Like,
Well,
if you're
we said
charging a regular laptop or
well, we said it lasts for about 150 hours. So it'll start to drain out after about 150 hours of continuous use. So that's if you continually charge your battery for a week, after a week, then you would need to actually recharge it. And that's when you just open the valve and you just give it a supplement. It depends on how much you use it.
Okay.
But it's relatively very
One
simple.
follow-up question based on that. So if you have a genetically modified organism and you remove it from your chamber, how are you going to handle issues with bio-waste and potentially introducing GMOs to the environment?
This raises sugar and oxygen. Oxygen is not harmful in the air. And sugar can be stored as a starch, or over time it will degrade.
I'm asking about the cells themselves.
If they ever got spilt out, is that what you're saying? And
Right. So if you have a genetically,
biohazard.
if you have a genetically modified organism and you're having to open this chamber every 150 hours to add new things. So if you open it, things can get out just as easy as they can go in. And if this is just a day-to-day person using it, what type of insurances can you provide a regulatory agency such as FDA or EPA?
First of all, you have to break down the gel that the cell is incorporated in. The gel is then solidified, it closes the charge itself. The gel is not harmful at all in any way, but you have to break down the gel all the way down to expose the cell. So for a normal consumer to do that, that'll be near impossible.
So they're fixed cells?
Yeah.
Fixed cells, okay.
So you guys said that you guys use agrobacterium?
yes, agrobacterium fluorobaceous.
Right, but exactly how did you use it?
So,
What genes did you put into it? How did
We
you
took
transform the
the
plant?
gene that's found in breast cancer. We got the gene sequence from the Institute of Cancer Research, and we inserted it into the TI plasmid, into the agrobacterium. And agrobacterium already like swims through the plant roots and incorporates its own DNA into plant cells.
Okay, but if you have an already growing plant and you incorporate agrobacterium, it's just gonna infect those cells. It's not gonna infect the entire plant.
Yes.
So how did you guys
No,
get
we would
around
actually, we'd only take those cells that were infected and put it into our device. We're not taking every single cell. So every cell,
Okay.
because agrobacteria, it grows into the root and causes a huge tumor in the root. So we just take those cells and put it into our device. So we're not taking like a random leaf cell on the top. We just take infected cells and put it into our device.
that? Okay, so agrobacterium doesn't infect the roots.
It doesn't.
We learned about it. Sarah taught us about
Y'all,
it.
I think y'all are thinking of the RI plasmid versus the TI plasmid.
TI plasmid.
So which one did y'all use? The
Yes.
TI plasmid. She just said the TI plasmid.
Yes, yes.
Yes.
So are y'all meaning to use the RI plasmid? Because that's the one that infects the roots.
We just learned that. Yes.
There you go.
Yes.
Any other questions from potential investors?
Well,
So the accessory that came with it, what's the accessory?
Because the accessories, because every device needs different voltage output. So if you give like 100 volt into a cell phone, which only requires 5 volt, you fry everything out. So these accessories would reduce the voltage, so you can charge. Yeah.
And then also the other accessories are for adapters. Like as for instance, your car charger can't directly plug in the USB, so it has an adapter to plug in a USB into your car and then into the device itself.
Yes. So for people who have children, if they open it, is the gel like toxic? Like
It's childproof.
Well, it's how the valve works. It's like it has a chamber, so when you open it, it's not actually letting anything.
It won't
out.
expose
Insert
the
stuff
contents.
into it to like, and then you close it and it allows it to flow into.
Also, the gel property is very similar to biological tissue, so there's no harm in it. It's very similar.
so this has to be exposed to sunlight regularly, right?
No, not regularly.
Not regularly.
Like I said, the conductive gel that we're using holds a charge as it is already. It's amplifying the charge that's coming from the cells. What the solar panel does is supplements that gel. So in case, like in general, it's a self-replicating.
So it holds the photon.
Holds everything inside the cell. So what it does is it's self-retaining. Basically, it's always replicating, it always replenishes its power. So it's low maintenance and you don't have to worry about it.
And to also, you will also know when the charge is running out. The light will actually flicker on it, and it'll tell you when the battery is actually running low. It actually does flicker.
It's going to indicate for you when you need
Yeah.
to utilize.
I think his hand.
So she,
When you're recharging after 150 hours, how are you, you're saying that stuff is not able to come out, you're just putting it in. Well, I didn't see where you were going to be able to insert that. What would you be using?
That is a prototype.
That's a prototype,
Yeah.
it's not the actual bomb. We just inherit something similar that you
So
Right.
how we gonna do that is we're gonna use the end
Valve
cap.
regulations.
The use is the end cap. The end cap is the system that's gonna be injected what it needs to finish.
So would that be included in the?
And the package when you
Yeah,
purchase
the
Of
cost.
course,
This
yeah.
product.
All the contents that you would need would be included.
We're talking $29.99 for the force and an accessory.
Adapter
If you
that
would like
you
to
may
buy
need or
an additional accessory at a cost of $10.
Right. So if the, when you're injecting it,
It's as simple as putting a little tab into the little cap itself, and you close it, and it'll self-eject it into the gel itself. So it will quench will neutralize the cell.
so if the adapter, I mean, if the force ran out, would you just put in another like gel in it, or what would you do?
If the force ran out,
Yeah, it's
like,
like after 150 hours.
oh no, it's regenerative, so you just add nutrients to the.
yeah.
Why would you add why would you put in another tube?
Because that would cost a lot more. If you, I think you're constantly going to somewhere and adding another, getting another tube, getting another tube. That's pretty much defeating the purpose of buying new batteries and everything. We wanted something that will will get rid of that. Well, you can just use for a long, long period of time. Because it's plant cells, so it needs nutrients. It would be intake. The plant cells would intake the nutrients.
I like how you also mentioned like water has a lot of different like nutrients in it. It has like metals, like minerals, different things in it that plants use on a regular basis.
Water, oxygen.
You're talking about, are you talking about like outgrowing the matrix once that's happened?
I mean, like.
What kind of stuff would we put in there?
No, for a user, like, how would I do that?
How would you replace the pore?
I mean,
Is that
you
what
don't
Add
you
nutrients.
don't before you just.
Add nutrients, yeah. We were explaining it earlier where you just twist the top and add the nutrient pellets.
Okay.
How are you guys trying to like? You guys say like, well, I guess economically, like once your product is all over the world, how are you gonna like maintain your company? You know, like, are you gonna come up with new products to help? You know, that are similar to this, or?
Yeah, well, right now, our company's relatively new, so this is the best we can do right now, but we're researching more devices into more research where one day it'll be smaller and actually output more voltage, you know? Right now we can only put in 100 volts, which is enough to power a laptop at most. But we're researching new ways where we're going to actually put in more volts so we can actually power an apartment or some kind of home or something like that. So it would be...
Essentially, we believe in the power of our product, though, and just changing that to consumer interest. So I don't think that
Basically,
we're going to expand
replacing batteries. That's what we're trying to do.
And I think,
That's what
you know, we're trying to reach out to you as an investor to, you know, join our company and help us develop new ways to create batteries.
monetary support and then providing feedback, certainly.
One more question. That's all we have time for.
Okay, so how much do the pellets cost and how often, you have to replace them every 150 hours roughly?
Roughly. That's
How
if
much
you can-
do they cost and do you get them in like a pack of, do you buy them singles or do you buy them in a pack?
Like I said, we're still developing ways that will be more consumer friendly. That's why right now we're trying to make it as easy as possible for someone that's technically challenged or not tech savvy to just simply just drop in a tab or leave it alone.
But how much is
We
it
can
cost?
estimate it'll cost around $5 for a pellet.
Not per pellet, but for like a pack.
Pack of pellet.
For-
All right.
And like he said, we don't have to keep track of hours or anything. It'll indicate when it's needed.
Thank you.